Okay, so why are traits heritable, at least partly, and why are they partly heritable, and why are they not wholly heritable? So we'll be going through these. So there are basically four, different possibilities about which try to explain the heritable bit. The first one is rather a mouthful, which is changing environments resulting in evolutionary stable equilibria. Um, so what that is later. The second is trade-offs, non-adaptive side effects, and then finally niche fitting. Let's look at that first one. Changing environments. What does this mean? Well, if you imagine that the environment isn't constant, okay, sometimes things are good, sometimes things are bad, and it varies, periodically. So we have periods of good times, maybe 20 years or a year or whatever of good times, and then we have less good times when we don't have as much food and the environment's more hostile. Then we might imagine that certain traits that might be adaptive in one environment and the other traits are less adaptive. But then when the environment changes, somehow then suddenly the the traits that were less adaptive in that first environment now become more adaptive. Let's try and make that a bit clearer. If you imagine a peppered moth, remember the good old peppered moth, we've got two forms of the peppered moth. We've got the peppered form, we've got the dark form. Now in the story I told you, lichen on trees meant that the peppered moth was more, the form of the peppered moth was more less easily preyed upon, because the peppered moth was harder to see because the colour blended in on the lichen. In that case, the dark form of the moth was more conspicuous and therefore would like to be eaten. In that case, you have the peppered form predominating with very few, if any, dark moths in existence, because they were all being eaten. They wouldn't have babies, so they wouldn't pass that trait on. When the environment changed and suddenly the pollution killed the lichen on the trees, then suddenly we have the other way around. We have the dark form being less easily spotted on trees, more likely to have babies, than a peppered form, which now sticks out like a sore thumb on dark wood bark. So then the dark form predominates and the peppered form either doesn't exist or exists in very small numbers. But imagine that rather than having a mass, just a single increase going from lichen to dark wood bark, let's imagine that this changed backwards and forwards due to some environmental conditions. For 20 years we had lichen, then 20 years of no lichen, then 20 years of lichen, then 20 years of no lichen. What we would have is actually we would tend to keep there wouldn't be a long enough period, if you like, of there being lichenless trees to completely eradicate the peppered form of the moth. So it would tend always to have a certain number of the dark form and the peppered form in the population. Yeah, when there was no lichen, the peppered form would be decreasing in numbers, and the dark form would be increasing in numbers. But then comes the switch, and we go to the other alternative, and then the dark form go down and the peppered form go up. This is the kind of argument we're making, and it may be that, for example, traits for communitarian traits, which want people to be part of a community, which about inclusiveness, when we like people and want to gather people together, may be favoured in hard times because we need to pull together to survive, whereas when we've got good times, maybe more selfish traits are favoured by natural selection because we don't need to pull together, we can look after ourselves, therefore individuals tend to do better if they're more selfish. And surprisingly, there is research from the non-human animal literature which shows that this may indeed be the case. So work by Drent here looks at great tits to birds, and they basically can measure how likely a particular individual is to explore the environment. Okay, so they can do behavioural measures of how likely a bird is, how far it flies, how readily it goes and looks for new stuff. So this is kind of a birdie equivalent of something like openness to experience or extroversion. They call them fast and slow explorers. And again, like extroversion, introversion, neuroticism, whatever, these aren't kind of categories. These are best thought of being opposite ends of a continuum. So these traits are heritable. And fast explorers, and literally heritable because they can actually look at the parents and measure the children's behaviour and find that there's similarities there. When food is scarce, fast explorers, those who get up and go and look for stuff, do better. The reason why they do better is, I guess, obviously they're more likely to find the scarce food than the ones who are slow explorers. The slow explorers are less likely to get out of the nest and go and find food. So they're less likely to get food to give to their kids. On the other hand, when food is plentiful, it's the slow explorers that do well. Why would the slow explorers do well when there's plenty of food? Well, they do well because they're more cautious, so they go and get the food, and they bring it back to the nest. Whereas the fast explorers are going foraging far and wide, and of course that puts them at greater risk for predation. So we've got a trade-off here. The risk of predation is balanced by, in the fast explorers, by the fact that they're more likely to get food. So when the environment changes, if you imagine the environment changes, and it does, so one year you'll get a lot of food, and next year you might not get much food. Some years the fast explorers do well and have lots of babies, and the slow explorers have fewer babies, but then the year after it might be the slow explorers that are having more babies. So these changing environments are leading to kind of stable equilibria in which the fast explorers and the slow explorers are both kept in a population, because sometimes one group does well and sometimes the other group does well because the environment's changing. Aggressive bluebirds colonize new areas faster than less aggressive bluebirds, so we've got a kind of survival thing where they're more likely to kind of colonize a new area and survive, but they tend to be poorer parents, which means that the kids are less likely to survive. So again, we get these kind of ideas. Guppies, the fish, guppies reared in swift water are bolder than those in calm water, and again this difference is heritable. Why is that? Because boldness is favoured in swift water because food is harder to obtain, similar to the fast explorers argument. These guys who are going out being bold, risking their neck in order to get food, are more likely to survive and reproduce by virtue of the fact that they're getting food than the less bold ones. So the less bold ones are being selected against, and the more bold ones are being selected for. However, when we have calm water, then timidity is favoured, boldness is disfavoured, because predators are more likely to exist in slow flowing water. So the bold ones are going out there and being more likely to be eaten. So caution is favoured in environments where there are predators such as slow moving water. So we can see here's a model for humans. Maybe some reason is that certain traits are adaptive in certain environments, whereas other traits are adaptive in other environments. Now this is very difficult to do the studies on humans, because these animals reproduce fairly quickly and grow up fairly quickly, so you can do a study in 10 years, could get you 10 or more generations of creatures in order to test it. But obviously humans, you would need probably a couple of 100 years in order to do the same kind of study, if indeed you could do it at all. But this is certainly a model for why variations is kept in the population. It's because sometimes guys do well in certain environments but less well in other environments, and if the environment changes, then there's enough in there to keep even the disfavoured trait in the population, because at some point that will again become favoured. Robins become aggressive. Robins that are aggressive are more likely to defend their territory, more likely to secure territory, but they're more likely to be eaten because they're aggressive. So if they're more likely to fight another robin and spend so much time fighting that they can often not attend to threats in the environment, such as predators. So again, this is kind of like going back to the stuff I talked about on anxiety, stuff I talked about emotion, about this kind of smoke detector principle, that it's important to detect threats in the environment, and these less aggressive robins may have traits which are more similar to those of people who are higher in trait anxiety, and that they're more likely to attend to threats. Trade-offs. Kind of already touched on this. There's a lot of overlap between these explanations, but some personality factors might have some advantages and some disadvantages, and the advantages and disadvantages, one doesn't outweigh the other. So for example, Nettle argues that extroverts may have more sex. So in other words, they have more offspring, but they're more likely to die than introverts. And we're talking about humans here, but kind of similar to what we're talking about with blue tits exploring the territory, and guppies exploring the territory. But they're more likely to die than introverts. So the argument here is that there's an advantage to extroverts, and they tend to have more offspring, so that trait of extroversion is more likely to go through to the next generation. But if they're more likely to die as well, then they're less likely to be able to look after those kids and protect them. So, in other words, the swings and roundabouts is that they're more likely to have kids, but those kids are less likely to survive, whereas the introverts have fewer kids, but the kids are more likely to survive. So it's a kind of a bit like the fast and slow life history theory, or the R and K selected in life history theory, or the CF continuum. That's in a developmental lecture that I did a few months ago. So Nettle tried to explore this with a reasonably large study with 545 adults, and he asked some bunch of questions, and he found that extroversion had a positive correlation with number of sexual partners, number of children by other partners, number of extramarital affairs. So these people do seem to probably push in more genetic material into the next generation. But on the other hand, extroversion also positively correlated with the number of hospital visits and the number of visits to the doctor, suggesting that maybe their slightly riskier way of living possibly is contributing to them being more likely to become ill and possibly more likely to die. He didn't actually find that the life expectancy of extroverts was lower than that of introverts, which would have been an important factor. So a kind of partial support here. But I guess you could also argue that in ancestral times, before there were hospitals and before there were doctors, then many of these injuries that the extroverts were taking to the doctor may have been more life-threatening than they are now. So this might have been made more sense in some kind of ancestral environment. It's a non-adaptive side effect. So maybe one possibility of these personality differences is not that they themselves have any kind of, so in other words, it's not extroversion or introversion that really makes a difference. The variation is something else underlying them. We know that genes have many effects on the body, so it could be that one effect of the gene might be to increase the immune system in somebody, and a side effect of that for some reason is that gene also happens to make people extrovert. So what is being selected for here isn't the personality traits, but some underlying thing like, quality of immune system or intelligence or whatever, and the traits are side effects. It's not terribly interesting explanation I have, but it's worth just flagging it up as a possibility. So for example, women live longer than men, but that is probably not an adaptation. It's a result of testosterone. So men have more testosterone than women, which makes women less aggressive and men more aggressive. That's the adaptive bit. And if you look at the Anne Campbell paper on Blackboard, she argues that actually it's not that men have been selected to be more aggressive, it's women have been selected to become less aggressive, which I think is an interesting spin on the way we normally think about these things. So it's the testosterone that's been selected for, the aggression that's been selected for or against, and the fact that one of these individuals lives a longer life than the other, one group of individuals live a longer life than the other, is neither here nor there. That's just a non-adaptive side effect of the real adaptive thing, and maybe it's the case with personality. The final thing I'm going to talk about here, and I've already mentioned this, is niche fitting. This is in the psychopathy lecture, the Darwinian medicine lecture, where I talk about psychopaths. And the presence of some traits provides opportunities for other traits. So when we've got a bunch of cooperators, then that gives the possibility of free riding as being a strategy. This is called frequency dependent selection. So when a lot of people are being kind to each other and cooperating with each other, then a possible strategy, a way of living, is to exploit those cooperators. Okay, so psychopathy could be if you like, a free rider strategy, which exists because of the large number of cooperators. Now, the reason it's called frequency dependent is the effectiveness of that strategy depends on how many people are doing it. If psychopaths are very few, maybe 1%, then the chances of any one cooperator bumping into one and being fleeced is pretty low, so cooperators will generally be open and honest and trust people. If, on the other hand, that the effectiveness of that psychopathic trait leads to these individuals increasing in number in a population, then people are going to encounter them more, are going to be less trusting and less open and honest. So that means that the effectiveness of psychopathy is going to decrease as a strategy because people are less liable to be exploited because they're less trusting, they're more suspicious. So the number goes down. So we can imagine this number of psychopaths possibly being kept at a constant number, a constant low number, as a result of frequency dependent selection. Okay, the next screencast I'm going to attempt to explain the non-heritable components by looking at some of these things.